Assalamu alaikum everyone. My name is Mohammad Tausif Islam. I'm from the CSC department of Batch 21. So this code here is from for the OpenCV coding task of week 2. So we are supposed to analyze this picture of the goat. So let's just dive right into it. As you can see at the very beginning, we have imported two libraries, the OpenCV and numerical Python. We're using shorthands for them so that it makes things a little bit more convenient to type in the actual code itself. In the very beginning, we are introducing three lines of code, and these three variables that we have declared here at the very beginning are just simply storing image data in three different forms. The first one is using the JPG file to store it in an RGB format. The second one is storing the same data, but by converting the first data into HSV format. So we're using the convert color function over here, as you can see. For the third one, we're again using, just like in the first one, the cv.imread function, as you can see over here, to convert it to and converting it directly into grayscale data, which is something that we've done inside here. Now, with that done, we are now introducing a new loop. This is a different function that is totally separated from this main code block. We are passing in here an argument that you can see, which is the image argument, and in the actual calling of the function, we are passing in the HSV data, the heat saturation value data. So before we actually work with it, we are going to introduce some bounds for the white and red regions. Now, to detect white, this is a good range to work with. And to detect red, this is a good range to work with. And I've extracted these values from the internet. So using the numerical array function, it allows us to input three different color space values. So the first one is for blue, the second one is for green, the third one is for red. And we have done this for both the lower bounds and upper bounds for both the colors. So we now have 4 lines of code over here. And we are now introduced two separate variables known as masked white and masked red. The purpose of these are to mask in the image. So we are only going to exhibit pixels in regions where we have white pixels. So for that, we have introduced this code, the in-range function to use. The first parameter is just simply the data that we want to process. The second two are the lower bounds and upper bounds respectively. We've done it twice for the masking white and masking red purpose. And just to showcase them, we have used the cv.imshow function to actually show these in two separate windows known as red detection and white detection. Now, we have actually called this function here by passing the HSV data, as I've mentioned before. So moving on, this is a separate function that is the analyze code image. Once again, we have passed in another image data, but this time I've passed the fgray image data, as you can see here at the very bottom, that line 52, which is the grayscale data. The reason to work with this is because grayscale images only have shades of gray, which means they have one single color space, and that is only the gray shading. It ranges from 0 to 255, where 0 represents totally dark or black pixels. 255 simply represents totally white pixels. So we want to work with that. It makes things a lot more easier. The first thing that we are doing over here, as you can see, is using this image.shapeway method to identify how many pixels we have in terms of height and how many pixels we have in terms of the width of the actual JPG. We are then assigning these values to h and w respectively, so that we now have the height and width of the image itself. We are assigning two separate variables, we're actually declaring two variables and assigning the values 0 to them, so that we can actually find out what is the maximum and the minimum values for these two variables. We then run a loop. So this is going to be a nested loop, as you can see. What we are essentially doing is, first of all, going through every row of pixels one by one. And for every row, we are also going through every column of pixels. So we are now looking at every single pixel one by one. We are converting these pixels to their equivalent grayscale values and comparing them with the maximum value that we have already in hand. In the event that the maximum value is actually less than the grayscale value of the active pixel, we are going to update the value of maximum value using this simple assignment operator. The same thing is performed for minimum purposes, but this one just has some different variable namings and different inequality signs, and it just works perfectly. Now, do note that this is going to be a bit inefficient because it uses a nested loop for a lot of pixels, and that is 960,000 pixels to be exact, because the actual JPG file is 1200 by 800 pixels. There is another way to actually do this is by using the min and maximum functions, but I just wanted to be a bit more practical. And in terms of these, so these are just simply used to calculate the average pixel values and count the number of non-zero pixels that we have. So let's just go through this line first. This one simply calculates the average pixel value of all the pixels that you have in the JPG file. And remember, it's again using the grayscale image data, so it's going to be only working on the single color space of the grayscale. It is written in this format, np.average, and we're passing the grayscale data over here, the image which we have already called at the very beginning. And then we have the count non-zero. So basically, like I've said before, pixels can come in different shades, where 0 represents totally dark pixels and 255 represents totally white pixels. Any pixel that has a value from 1 to 255 inclusive are considered non-zero pixels. This function right here that comes with numerical Python is basically responsible for taking into account all the pixels that have a value from 1 to 255 included. And any pixel that has a value of 0 is simply excluded out of it. So this is what this line does. And for the sake of the first part, I'm going to comment out these two lines of code because these are separate purposes. These lines are just simply to print out these values that we have obtained with all these functions and this looping around and everything like that. Now, this is the function that we call at the very end. As you can see, we have passed the grayscale data, just like that, at the very beginning. And at the end, we have this one line of code that is cv.waitKey. So this basically waits for any input that you will give through the keyboard. But setting this timer, which is in milliseconds, to 0 simply means that the program is infinitely going to wait until you give an input on the keyboard. So whenever we run this program, all the outputs are going to remain shown forever. And with that, it's not going to go away on its own. Now, if I were to actually compile this code, it takes a bit of time, not to mention because of this nested loop here. But as you can see, the windows are showing up, the code is compiled correctly, and you can finally see these two shades. This is the white detection window. As you can see, these regions which are white in color show large concentrations of white pixels, and you can compare it with the actual image of the goat. So these trousers and there are stripes of white, the 14 is white, and there's this white trace on the shoulder. These are exactly copied over here, and you can also see some sponsorships white font, which is also shown in message jersey. As for the red part, you can see that everywhere else it is red, it's white. The 14 is blacked out. It's because 14 is white in color, so it's supposed to be shown in black. But everywhere else, the jersey and even these stripes of red on message jersey is being shown in this region. And as for the other values that we try to print out, you can see that there are many different values over here. So the maximum pixel value is 255, which means in this photo there is at least one pixel that is totally white in color, and there is also a minimum value of 0, which means there is one pixel probably in this hair which has a total value of 0, which means it's totally black. It has no source of colors emitting from it. The average value is just a function that is used by the Python itself, OpenCV itself. It calculates the average pixel value of all the pixels here in the grayscale format. We are also calculating the total number of non-zero pixels, which is 959,283 pixels, and the number of 0 pixels. So 0 pixels simply represents pixels that are totally 0 in terms of magnitude. Now, as I was saying, I commented out two lines of code over here. If I kill the terminal first, and if I were to remove these commentations and compile this code again, this is a separate purpose. What it's doing essentially is this function that I've written is basically responsible for calculating the total number of pixels that are 0 in magnitude. So as you can see, the format here is written. It's the same way. It uses a numerical Python library function, and what it's simply doing is that it's summing up all the number of pixels that are black in magnitude, or that are 0 in magnitude, not black in magnitude. Image equals to 0 simply represents that very same thing. Like any pixel that has a value of 0 is going to be assigned into this and summed up. So count 0 essentially has all the pixels that are 0 in magnitude. So that is being shown over here. I printed it out directly by passing in the count 0 variable. And I also have 717 again, which is the same as previously. Because previously what I did was subtracted the number of non-zero pixels from the total number of pixels, which is height star w. As before, mentioned before, height represents the total number of pixels in the height, and w represents the width number of pixels. So if we just multiply them, we get the total number of pixels. And if you were to add these two values, you would get 960,000 pixels, which makes sense because that is the total number of pixels that compile this JPG image. And that pretty much concludes my code of the OpenCV. Thank you very much for watching. Assalamu alaikum wa rahmatullah.